Hello everybody and welcome to another cool YouTube video. In this video we will train a deep neural network using TensorFlow. So we're gonna do is the TensorFlow Fashion MNIST dataset. So we will train a deep neural network for classifying the images of clothing like t-shirts, sneakers, ankle boots and like that. So we're gonna use the neural networks. So we'll compile the model, train the model, everything. So if you are new to my YouTube channel, first subscribe it before watching this tutorial. So let's start. So before training the neural network, we have to install the TensorFlow and its dataset. So if you are using Windows, you can use pip install TensorFlow. If you are using Python package index as the virtual environment. If you are using Conda, you can do is conda/n create TF TensorFlow. You can, and next you have to use conda activate. So by that way you can install TensorFlow, and once TensorFlow is installed, you can check import TensorFlow STF, print TensorFlow dot underscore version. This will tell you the version of the TensorFlow. So if you are saving and running your file, you first get these instructions error, and if you're getting these instructions error, the simple point is your TensorFlow is installed, and by checking the TensorFlow version, you can use print TensorFlow dot underscore version like that line. Okay, we got 2.3.1, that is the latest version which we have installed. Okay, so TensorFlow is successfully installed. Now I'll tell you about the Fashion MNIST dataset. So we have 60,000 training images, and the testing images are the 10,000 testing images. So we have 60,000 training images, and the testing images are 10,000, and each image is a 28 by 28 pixel, and we use NumPy. So import NumPy as NP, import TensorFlow STF, and for pre-processing the data we use matplotlib. So import matplotlib.pyplot.spt, and for training the model, evaluating the model, compiling the model, we use TensorFlow Keras. So from TensorFlow import Keras. So the process is going into the 6 steps. First we have to import the dataset. So this is the first step. We have to import the dataset. So we use keras.dataset.fashionMNIST.load data. By that way you can load your dataset. So what is actually this Fashion MNIST dataset? This contains some ankle boots images, t-shirt images, trouser images, and we will train a deep neural network to classify these images. So we put into a tuple x train, y train, x test, y test. Okay, what is actually this x train, y train, x test, y test? X train is the 60,000 images of ankle boots, t-shirt, trousers and tops, and y train is a 1D array, a NumPy 1D array which contains the value between 0 to 9, and each value represents some ID. Okay, and X test represents the 10,000 images again of the ankle boots and shoes, and Y test contains each and every ID for that images. So we have t-shirts, ankle boots, sneakers, and like that. And we can classify, we can show, we can predict that which one is a t-shirt and trouser, but we can train a deep neural network to classify that images. So when we using print x train and expression this, we got a array. This is not a floating point array, but we need a floating point array. Okay, and when we y train, we got a array which contains the numbers between 0 to 9, 60,000 elements in the y train array. Okay, now x test, and so now we have to normalize the data. So the values are from the range 0 to 1. So before feeding them to the neural network, we have to divide it by the value 225.0, so that we get each and every value in the range of 0 to 1. And why we divide with the number 255.0? Because the RGB pattern contains the numbers between 0 to 255. Okay. Running and saving your file, you get xtest index position 0. Let's check for particular image. Okay. So the xtest index position 0, maybe it's a ankle boot image or t-shirt, but we get the array value between the 0 to 1. 0 to 1, and this is how you can normalize the data. This is the important step. Now we use pt.im show xjoin index position 0. It's time to pre-processing the data, and now we use pt.show. Okay, so by using matplotlib we can show that image. Maybe it's a ankle boot or maybe it's a shoe, so we don't know actually which one it is, so we will pre-processing the data. And now we use cmap equal tree. Okay, xtest index position 0, this is a ankle boot. Okay, we can check for any more value like xtest index position 0, xtest index position 0. Okay, save your file and run that. So okay, maybe we don't know, maybe it's a top or not. So how you can predict that things? So white train and white test contains the numbers in the range of 0 to 9, and each one has a particular ID, so we will use this. So we have items here, so the items, now we create a list of all of the items which are included in this xtrain in images. So what type of images we have? So if we're talking about the Fashion MNIST dataset, we have t-shirts images, trouser images, pullover, and the dress, and sandal, and shirts, and sneakers, bag, ankle boot. It's okay if you don't understand all the details, we will make it simple, easy for you. So we have 28 by 28 pixel, and each one has a particular ID according to the white train and white test. So these according to your 0 to 9. White train has 0 to 9, and we'll use that. Okay, so we create 25 subplots, so we apply the loop 25 times, and now we use 5 comma 5 comma I plus 1. By that way you can create the 25 subplots from 1 to 25. Okay, and now we use a pt.grid of and axis of. We don't want to show the axis and the grids here. Okay, and now we use values equal to items white train index position I. What is this hack actually? So white train, let's say white train index position 0 is equal to 3, because we know white train contains the number from 0 to 9. And what is according to items index position 3? We got the dress, and the image is the dress, and white train index position 4. Or let's say white train index position 14 is equal to 2. We assuming this. And what is this items index position 2? That is the pullover image. So we will use that as a text. So we use pt.text 0, 0, values, and pt.im show xtrain index position I. So we get the first 25 images, and along with that each and every image has some name. Save your file and run it. Okay, items is not defined. Okay, spelling error. Fine. Okay, now you can see we got ankle boot, t-shirt, dress, ankle boots, dress, trouser, course. You can see we get the name of each and every each and every image with its name, so that we can easily classify which one is a shoe or not. Okay, now we apply the subplot 100, so that's how you can create 100 subplots, and we got each and everyone has a name: dress, ankle boots, bag. Simply is that. That is how you can pre-process the Fashion MNIST data. That is how you can simply pre-processing the images of clothing data sets. Okay, now we use xtrain index position I. That is fine. Okay, that is how you can pre-process the data. Next step is to creating the model. Okay, So the next step is to create the model, set up the layers. Okay, so for creating the model, we use TensorFlow Keras as backend. And after creating the model, we have to compile the model, train the model, evaluating the result, predicting the loss and accuracy. Okay, so now we have to create the model and set up the layers. So we use model is equal to, and we use Keras sequential layers here. So sequential model and Keras.sequential. By that way, you can create a model. And now we use Keras.layers.flatten, and input shape is equal to 28 by 28 pixel, because the basic building of a neural network is the layer, and the layers extract the representation from the data fed into them. Most layers, such as the TensorFlow.layers.dense, have parameters that are learned during when training. So we use activation is equal to rel, and now we use keras.layers.dense 10. So the first layer in this network, TensorFlow.keras.layers.flatten, transforms your images from a two-dimensional array. So it will convert 3D array to 2D array of the 28 by 28 pixel. And after your pixels are flattened, we have the network, which consists of a sequence of two layers, dense layer, and these are densely connected or fully connected neural layer. So we use model.summary for checking the summary of our model. So I'm at the point that the first dense layer has 128 nodes, or the second layer has a array with the length of 10. And when we run our program, you can see that we got flatten layer that has a none comma 784 shape, and the dense layer has 128 nodes, and the final dense layer has the array of length 10. That is what we get in the output. And we have a total parameter for training. Trainable parameter are 101770, and the non-trainable parameter are 0, because till now we have not trained the model. Okay, now we see that how you can compile the model. So we see actually that how you can so now we see that how you can create the model. Now we have to compile the model. So we use loss, optimizer, and the matrices. So before training model, we have to compile it using loss, optimizer, and matrices. What is actually the loss, function, optimizer, and matrices? We will simple defining for you. So we use model.compile and this optimizer. So first parameter is the optimizer, and optimizer tells me that how the model is updated based on the data it sees and its loss function. So we use optimizer is equal to sgd, and the next parameter is the loss. So the loss function measures how accurate the model is accurate using training, and what's the loss we get. So we use keras.losses.mean square error. This is one type of loss. And the next parameter is the matrices. So we use matrices is equal to accuracy, and this is used to monitor the training and the testing steps. Save your file and run it. Okay, we got the subplots. Okay, we got the trainable model summary here, and we don't get any error. That means our model is fully compiled. That is important step. Now we have to train the model. So for training the model, we use approaches here. So training the model. Now we get two steps remaining: training the model and compiling the and evaluating the results. So we use model.fit x train comma y train here. So we have to train the model, and we use the third parameter, which is the approaches 10. So as the model trained, the loss and the accuracy matrices are displayed, which you can see. Okay, so as the model trains, the loss and the accuracy matrices are displayed, and you can see we got approaches 1 to 10, and we'll show you that the model reaches an accuracy of about 0.09%, maximum 0.08, like that. Aperture, okay, we got the loss which is 1.3453 and the accuracy is the 0.08, which is the 0.087, which is the 87% our model is accurate of the training data. Fine. Final step. Yes, this is the final step, which is evaluating the accuracy. Now we have to evaluate the accuracy. So we use model.evaluate. Okay, so we use model.evaluate, and now we use here is x test, y test, these two parameters here. So as the model train, next we have to compare the model perform on the test data set. So our both contain the number between 0, 1, 2, only 3 numbers. Now if we put this inside a tuple, so we check how much accurate our model is and what is the loss. We need these two parameter, loss and accuracy here. So we will print the message that what is the loss and what is the accuracy for training that deep neural network. So we use testing loss plus string of this test loss, because we know that this test loss, maybe it's an integer or float, so we convert that into a string so that we don't get any error when we print the message. Okay, just like that we need accuracy, so we use accuracy and plus string of accuracy, test accuracy, like that. Okay, so we convert that into a string so that we don't get any error. That is the Python basic. Okay, we get the approaches, and these approaches are actually the processing steps each and every time. So each and every time it will process 10 steps. So we got the testing loss 1.14 and the accuracy is 0.08. This is not the percentage. So by converting into the percentage, you can multiply the test accuracy with the 100. So fine. Now we will, if we multiply the result with 100, okay, the ETA, expected time, okay, testing loss is 1.14 and the accuracy is the 12%. So our model is 12% accurate, and this is one of the final step, that how you can evaluate the model. Fine. That is your first ever deep neural network using TensorFlow for classify images of clothing. So that is how you can classify the images. I will repeat what we have done here. So we use import TensorFlow, NumPy, Matplotlib and Keras, like that. And the first step is to import the dataset. So we use keras.dataset.fashionMNIST.load data using the instructions for importing the dataset. And now we have to normalize the data. So we use NumPy for normalizing the data. And next we have to pre-process the data and classify that which one is a shoe or not. So we use Matplotlib as backend for showing the images, and next we have to create the model. So we create the model using Keras. Next we have to compile the model. So we compile our model, and next we fit the model, train the model, print the results. That is all about your first ever deep neural network for classifying the images. If you like this video, like, share and subscribe my channel for Python, JavaScript and machine learning videos. Otherwise, thank you for watching this video.